And hello, everyone, and welcome back. Hope everyone's having a nice weekend so far. So, where are we at the moment? We're looking at function definitions, but also function calls, which is kind of where we're somewhat stuck in the middle of at the moment. So, working around some of Rust's not necessarily limitations, but I suppose constraints on how we can implement it. So we're currently up so we're currently working around defining our environments and our stacks. So the idea being that if we call a function, then we'll be defining this stack of sorts, this kind of stack of environments, where at the lowest level we have kind of the global environment, where if you define something in the global scope, you can access that. But then, each time we call a function within another function, then we add extra, what they typically be called our frames. We add extra frames to that stack so that variables defined within narrower and narrower scopes are shadowing the variables defined in outer scopes. And the tricky part about this is that even in kind of a single threaded environment, but more so in a in a concurrent, or more so a parallel an environment that supports parallelism, uh, each frame could be used, or could be each stack frame could be referenced by more than one function, I believe. Yeah, that makes sense. So the idea being that if you are in a function and you spawn off a parallel process, then not only will the parallel process want to reference the current stack frame and also all the stack frames above it, but the currently executing thread of execution will want to access those same frames as well. So we run into this situation. Well, there are kind of two things we have to be concerned with here and almost work around in the case of Rust. And the first is, number one, even just getting references to those different frames. So one approach I was trying last week was just using basic references, which more and more seemed like it wasn't going to be a viable option. Uh, it's if we did want to have, say, this kind of like we just essentially be developing kind of a linked list approach here, which doesn't seem to be very tenable in Rust, in particular due to an avoidance of circular references. The second part of the equation, though, that is relevant is if we are dealing with parallel processes, we have to be kind of careful around parallel state mutation. And again, Rust is very strict when it comes to things like that. And if we wanted to do it in a safe way, i.e., not using Rust's uh, unsafe blocks right out, we would likely have to use some kind of mutex and reference counting to work around that potential for parallel state mutation, or even just accessing the same state from different places. So that's kind of the can of worms that we opened up last week, and that I'll be looking at today. So just in terms of the code that we have so far, or the main area that we're looking at the moment, is this environment construct. So the idea here is that, or at least the idea last week, was we eventually had a linked stack or a linked list of environments. So each stack was going to be made up of a single frame, which then pointed to another kind of environment. and those environment frames could actually be shared. Now, one thing that I just realized off the top of my head now is that, it depends on exactly how we're going to be supporting parallelism that defines how relevant this approach is. So, for example, if we said that new threads of execution don't necessarily share the same in kind of environment as the thread that it got spawned from, that could help things for us. Though the only thing that about that is, in general, we're probably going to want to give most threads access to the global environment, even if that's accessing, constant variables and things like that. And again, this is working towards kind of a fairly lightweight interpreted programming language. So, one where we're probably want to keep things flexible and make things as easy as possible. So those kind of cheats where you can, just access enclosing scope easily probably is something that we want to do. So we instead of taking a shortcut of maybe either copying the environment, cloning the environment, or just starting with a new blank environment, they're probably not things that we're going to want to look at, or to look at as an option. So that brings us back to this current approach where we're going to have, we're going to be referencing parent environments effectively. And so I did a very minor amount of research in the interim, but the two approaches that we're going to take that are going to be feasible here are, well, first of all, what we're probably going to need to do is introduce a mutex here, so that we could take this kind of, still it'll be a linked approach, but where we have some kind of arc-mutex here, and I'll get into this a bit more later, mostly because I can't remember all of the details of it myself. So we can take the approach of still having a linked list, but it's defined, or the references are reference counted and protected by mutexes to guard us in the case where we introduce parallelism. And the other option we have as well is to this is effectively defining a linked list. What we could do instead is say that an environment, we have some kind of global environment pool, and for example, each frame, we just have a collection of frames, which again is going to be a collection of arc-mutexes of these I could call this frame actually, and it would be a collection of these guys. In fact, I could probably define a new type to represent that. Actually, I might just do that now. I'll call it an end frame. I can't remember how type aliasing works in Rust, actually. Rust type alias. So I'll just give a quick look into that. Type alias is equal to that. So maybe if I do something like that, and I'm not getting an error due to that syntax, so that would probably be all right. So so going back to this, we either have the linked list approach, or we could take this approach where we have a vector that defines all the of this pool of frames, and an environment then would be some kind of vector of indices into that, or indexes into those frames. So it's kind of a more or less the same approach, but a different representation. The only thing to consider really is, is there a difference in terms of performance with, say, accessing it in these different approaches? So to consider how this will be used in practice, let's take a look here. So, for example, so it all kind of the practicality of these different approaches kind of boils down to, for the most part, this lookup function get. And get, in the case of, so if we have, I'll call this, and again, most of this is going to be more pseudocode at the moment. This probably, I probably won't be compiling this as such, but just trying to figure out the relative efficacy of the two different approaches. So if we take a look at this approach, which is linked approach, and this approach, which is a vector approach. And the first metric we're going to evaluate them on is just in terms of, number one, how efficient they are, but then the second metric will be if they're, relatively the same performance, which is kind of, which one of the two is easier to work with. So those will be the two dimensions that we'll compare these on. So so for env2 we'll have frames. Now this isn't a very clear definition, so this is a little too pseudo-y. So maybe we'll make env2 will be that. Actually, there are a few approaches we could take there. So so we could say that's so those are the frame indexes, and then we could say frames. And again, I'm using structs here. They'd probably be better as just regular and global. Oh, sugar, is the audio off again? Thanks for highlighting that. So I can see on OBS it seems to be picking up audio, but maybe it's not streaming properly. Thanks for highlighting that. I'll just check it quickly on Twitch myself. I'd hate to have to start all over again as well. So just judging from a quick test on my phone on Twitch, it looks like the audio is coming through, but I'll just try it again 1 second. Okay, cool. Well, thanks very much for alerting me anyway, just in case. I, kind of paranoid about that now since last session as well, where I probably went on for 5 or 10 minutes before before I realized I was muted. So thanks for highlighting it regardless. So yeah, cool stuff. So we have frames now, and so this will be, kind of our I'll just call frames pool to be explicit. And so each thread of execution will have this kind of list of indexes into the frames pool. So this will likely need some kind of reference into that as well. But the difference here will be each environment will be referencing the same frame pool, whereas up here the parent environments are all going to be different. This is very okay. I'm going to be straight up that this is quite messy. This is kind of nearly just you know like letting my own thoughts flow and seeing what this kind of stuff would look like. So not all of this is necessarily going to be fit for purpose right away, but it should be enough to allow us to evaluate the two options. So if we were to consider again, so I'll put it open here on the left hand side. If we were looking at the linked approach first, what would that look like? And maybe I'll create a new screen for this, just to can I set the syntax to Rust? Yeah. So so let's take a look at just this on its own first. So again, this is the linked version first. So if we said, so this version would actually be more or less the same as the linked version that we had before, except that now it should work now that we have actual atomic references and mutexes. And again, this is something that I'll need to look up because it's been a while since I looked at arc-mutexes in Rust. And just a bit of background on these. The reason we have both of those is because Rust is quite nice in terms of well, it's complex in some senses, but Rust, I suppose, imposes a number of rules with its borrow checker. And instead of having, say, this kind of, almost, super type that just relaxes all of those rules, they actually separated some type, separated these, I suppose, constraint relaxers into different types. So mutex it specifically says, okay, in general, in Rust, only one thing can have, a reference to something, or can have ownership of something else. And if I recall correctly, mutex will allow you to have multiple owners of the same thing, but only one of those will then be able to act upon that ownership at a given time, and will then need to give that ownership back in order for other threads to continue executing with it. Then reference counting actually, I can't even remember the gist of it, but I think it's something like you can have references to the same data in totally different processes, I suppose. Yeah, in fact, I don't even remember it well enough to give even a vague a vague description of it. So actually, I won't go into it now. But let's take a look at how some of this stuff works. I think you wrap the mutex in the arc as well. I don't think you do mutex arc. Yeah, it's arc-mutex in general. And Yeah, so that's about what we're looking for, I believe. So and so how do we dereference these things as well? So first we put a lock on it, which will allow us to get a reference to the thing in the mutex. Unwrap. Not actually sure what unwrapping is doing here. Is that is that evaluating the lock? I have to take a look at another reference. It's been a while since I've looked at this stuff. Poisoning. Yes, so let's see. We unwrap the return value to assert that we are not expecting threads to ever fail while holding the lock. Yeah, so we'll probably just retain that. The shared state can only be accessed once the lock is held. Our non-atomic increment, which I believe is arc, is safe because we're the only thread which can access the shared state when the lock is held. Yeah, so that okay, so we get this mutable data and we dereference that in order to modify the underlying data. Okay, so let's see. So if we were to use that, I'm just going to make these screens sit side by side a bit so I can reference that. And let's see. So we would be starting off, yeah, in the usual way of getting the current environment would be self again, but this time the difference being that before we actually access the environment values, we'll actually have to, oh no, so that'll be all right. So it'll be this time when we are accessing the parent, first we'll have to get a lock on it. So that means that, so in this case, env isn't going to be set here, it'll be set further down. And instead we'll have parent lock unwrap. And again, this is something that will just cause us to panic, I believe, if the constraints or the assertion fails. So this will allow us to lock the parent environment and have sole access to it. So in fact, it could be something as simple as that. Now, the only issue here is how this works in the context of the while loop. So yeah, we have this kind of recursive functionality, but we're using a while loop to evaluate it. Yeah, we might have to restructure this while loop in order to actually work around the lock. So we might even have to, for the current frame, even though it's a little bit of duplicate, so it was nice the structure we had here, because we could say, okay, we'll treat the current frame, we'll pretend that this could be an optional frame so that we can treat it. like the rest of the frames in this while loop. But what we'll actually have to do here is treat it, just treat it specially. So what we'll do here is, first of all, so we know env. So first we'll start off with self, and we'll access the frame of self, and if there's a value there, then we return it, and that's all right. So then the next thing we do is we'll get the parent, and so first we'll start off with the reference to the parent, and so we'll do that. And first of all, if the parent actually exists, like if we have a parent. Thanks very much, Twitch Live Lover. Yeah, like quite I would say the language itself is relatively straightforward, but the one I'm implementing, but doing it in Rust in particular is a bit more of a challenge. In particular, today's session is definitely one of the trickier ones I've been working on. The rest has yeah, well, that's the thing. I'm hoping that yeah, at least the Rust being the underlying language means that especially for things like concurrency and issues like that, where it would be in another language, it would be very easy to just say, okay, that works, and so or we'll just use references for everything, and have mutations all over the place and not really worry about it. Rust does force you to think about that kind of up front, which introduces some complexity here in the implementation, but it means long term, yeah, hopefully that'll pay off in terms of security and memory safety and parallel safety and things like that. So yeah, hopefully it'll be providing good payoff. So yeah, so once we've verified that we have a parent environment, then we actually want to lock it. So we'll lock that. So variable names are going to get a little messy here, but the actual implementation here is so tricky that I'm going to forgive myself for that for the moment. So now that we've locked the parent environment and we have sole ownership over this environment, that will allow us to browse that environment's frames at our leisure. And so then we do the usual method of if there is a matching name in that environment, then we return it. Otherwise, the new parent is going to be the parent of the environment that we currently have a reference to, and so we're not assigning to the data, so we probably don't need to dereference it. We also don't need to make it mutable too. Now this seems like it would work in theory. I'm not sure how the borrow checker would react to it, but again, this is more at the moment just fleshing out the idea and figuring out how it could work in a theoretical sense and evaluating the performance first. So just thinking about this part, this should be all right as well, because one tricky part I was thinking here is if we're within, say, what we would call a critical section, and we've unlocked this other piece of memory, would we then need to unlock this nested piece of memory, kind of nested piece of memory as well? And we don't have to actually, because we won't be unlocking this parent environment until the next loop. So that's kind of nice. So what we're returning here isn't an unlocked piece of memory. We're actually assigning, while we're in the critical section, we're extracting just a reference again, and then the reference will get unwrapped the next time around the loop. Now there was another comment in here, so I'll just take a look. If I would write a programming language, I wouldn't base it on any programming language. Yeah, that's an interesting thought. And I think some of the best opportunities for those was back when programming languages were being developed first, because there was nothing to compare it to. And I feel like that gave rise to a lot of innovation just in terms of what could a programming language even look like. So, some of my early inspiration in this area came from my late professor in college, Mr. Joseph Manning, and like he had quite an in-depth knowledge of just programming languages in general, but brought this to my attention that some of the early programming languages, so you're talking about APL, Prolog, Lisp, and Eiffel and all these kind of things were just, they were kind of developed in the very early days of programming, and nearly it seemed nearly as a result of that they are so unique even in their appearance, like Lisp with its kind of strange nesting of just lists and lists, and list processing language. It just consists entirely of lists, and then you have, yeah, the likes of APL, which looks like an alien programming language, and there was also Prolog, which not even just in terms of uh, the uh, the way it looked, but also the fact that it used this kind of breadth first search. That it was a logic programming language using breadth first search to evaluate uh, to actually evaluate the programs, just made these such unique languages early on. In general, for I suppose more practical reasons, we have definitely converged on having programming languages look more and more like C descendants. So if you programmed in JavaScript, Java, C Sharp, C, C++, Rust, Go, any of these kind of languages, a lot of these are going to kind of at least look and feel quite familiar. And I suppose there are very practical advantages of this. It does reduce uh, the overhead of learning those kind of languages. But then in terms of, actually innovating and yeah, I suppose it's, they're two different trade-offs. One of the benefits of having a language, and actually Haskell is another one. I know there are prior languages that kind of shared a similar syntax, but was it Miranda or something? I think there were a couple of those. But one of the benefits of having a totally novel syntax and things like that is it nearly forces you to think in a different way. Whereas, it's very, and I work with, say, uh, programmers in lots of different disciplines. It's very easy, particularly say with Go is a programming language where again it shares syntax with a lot of these modern languages, but because it's kind of C style syntax, and shares, you can write code in a C style in Go, and there's nothing stopping you from doing that. So for example, it's very easy to find lots of projects online where people are writing the code base in Go, but they're effectively writing Java or JavaScript or something like that. And Go tries to avoid that using idioms, but there's nothing necessarily stopping you from writing your code in a way that you would write it in another language. Whereas, yeah, if you talk about basing it, like not basing it on another language, that has a nice appeal in itself because it forces the programmer to just think about things differently. Another one actually is Forth, and that kind of stack based or factor, where it's almost like extreme reverse Polish notation, where yeah, you almost define your program in terms of a stack of operations. And again, these are all Turing complete languages, but the way you have to think about how that language will get evaluated and how you structure your program is totally unique. And even just like again, these are all just exercises to get you to think about programs from different angles and expand your worldview. So it's yeah, making a language not based on uh, any existing language can definitely is definitely worth pursuing as well in its own right, just to push the boundaries of what we think of when we think of programming. But anyway, tangent over. I'll get back into this. So we have this set up, and for evaluating a lookup with a linked list style environment. And for the most part, this looks on paper like it could work, and it's relatively efficient. So if we take a look at where we could encounter bottlenecks, so what's happening is if we have two threads pointing at basically the same environment stack or stack of frames, then they would be, if they perform a lookup, then they're going to be accessing the same path of frames at the same time, more or less. But because of this setup, at least the main thing we want to avoid is deadlock, where for whatever reason, some combination of locks and unlocks um, and waiting is preventing our program from evaluating further, where we just reach this stage where the program just can't proceed. And I think for the most part we're safe from that here. And it's also relatively efficient because of we only hold the lock for a very short a very well defined narrow scope of time. So you basically just check the current environment stack or current environment frame. If it doesn't have what you're looking for, then you grab a reference to the next to the parent environment, and then you release the lock. So it's relatively performant. And in fact, am I doing something wrong here? I think no, it is env parent. I'm doing something wrong here in terms of this should be env, but that's all right. So yeah, for the most part, that's fairly that that's fairly usable as an approach, I believe. So then if I took a look at then the vector-based approach, what would that look like? So again, I'll copy this basic implementation. So this is a vector approach. I'll update the syntax, and let's see if we had. So the idea here would be, in fact, I'm not going to rewrite this because I feel like the linked list approach is actually valid enough on its own that I'm not going to probably spend too much time on the vector approach. I'm actually going to just kind of lay it out in pseudocode. So we'll start off with, so we'll have this environment defined in terms of indexes, and then this inner loop is actually more or less going to be doing the same thing as we were doing up here. So we'd be going, for frame index in, indexes, then we would be saying, grab, get frame, or, for I in index, we'd get frame I from the pool, lock it, and then if we find what we're looking for, then we return found v, return it, otherwise continue on with that loop. Big difference here, actually, I'm not sure, it actually doesn't really make much of a difference, is the fact that in this approach, in fact, I'll start off with this approach. In this approach, it's the parent environment, or it's the locked frame that contains the reference to the parent. So we can only grab the reference to the parent while the environment is locked. However, in this approach, because we have all the indexes in a single array, we don't need to do that. We can actually, the critical section is actually that much slightly smaller. So we remove, basically the main difference between these two approaches is that in the linked list approach, this part is within the critical section where we get a reference to the next stacked frame. But in this approach, it would be outside it. It would effectively be evaluated in the loop. So in that way, the two approaches are actually fairly similar in terms of, I would say anyway, from a a very, very top level view. It looks like the two approaches are very similar in that regard, only for that difference in how the reference to the next stack element gets retrieved. The next dimension that I was going to compare them on is then so just in terms of that, for that reason alone, I would say the vector approach does win out. It's got a marginal benefit of releasing the lock that bit earlier. However, the other metric to evaluate it on then is in terms of ease of use. And in that regard, I feel like the linked list approach might actually be slightly easier to use. So with the vector approach, there are a couple of things to consider. One is the fact that we'll be introducing this lifetime variable if we're using a global kind of frame pool. The whole idea of a frame pool is a little strange. We'd also actually another interesting thing is that we have we'd have to be very careful about references to the frame pool as well, because again, if we're going to be adding and removing all these items from the frame pool, we're going to have to update any references or any indexes referring into the frame pool as well. So even though the frame pool approach has that slight performance benefit, which I think is worth noting and being aware of. In fact, I'll even just jot that down. Env pool releases lock earlier. So even though there is that slight benefit of the pooled approach, the actual usability of the linked list approach actually sets the linked list approach ahead. And in that regard, I'm actually going to use the linked list approach because it just seems simpler to implement, really. So what I'll do is I'll get rid of all of this, and now we'll get back to actually trying to make this thing work. So I'm going to pull open this this window again and get it full sized. Let's see, is that correct on the stream? Yeah. So where are we now? So I've probably introduced a fair number of errors just there. So I'll remove the vector stuff. I'll remove that comment. This will just be called env. We have the frame. Probably don't need to separate that out into, even though it, I think it makes sense as its own type, but I don't think it's wholly necessary right now to have that as its own type. So we have the environment, and we're implementing the environment. I'll have to remove the ref, all this static stuff, I think. Although they can they stay for the moment? I don't think they're hurting anything, and then I can remove them in a minute if they're no longer necessary. So arc and mutex haven't actually been imported, so they're both in standards. I assume they're both in standard sync. Whoops. So we have mutex in here, and I assume arc is in here as well. Env doesn't have this field 346, so I'll have to update those kind of things to frame. 408. I do prefer the word frame for that concept. 31. Well, that's in main. 31, and we have vals, and in val, that's line 346. Parent is some environment. Yeah, so we need to start introducing a mutex in there now. So this is the syntax. So you'd use arc-new and mutex-new. Yeah, fairly standard, I think. So we now have this new stack frame. Oh yeah, and we're in the context of defining a new function call. So we have this new environment frame, and we want to hold on to a reference to the outer environment. Now the only tricky thing here is that will need to take ownership of the environment. So I'm guessing that all of the parameters, parameter types will need to be updated as well. So that signature is going to permeate all the function or the parameter definitions. So a clone reference. Yeah, because we're not going to really be able to do a new mutex there we're going to have to do a clone of the reference. So so yeah, I'll probably have to update all of those now. I wonder, can I do a and would it make sense to define a new type for the environment in that case? Let's see. Just thinking, if we're going to have an arc-mutex for all of these environments anyway, no, I'm overthinking it. What I'm going to do is just try it out and see where it gets us. So so I'll go arc-mutex. Maybe I'll do it like this so that I can repeat it with Vim. So arc-mutex env, and I'll probably jump between all these statics. So we'll go static. Oh, this is going to have to probably would have had to do this at some point anyway, replacing the environment with this kind of mutex protected mechanism. Yeah, I think that was going to have to happen at some stage anyway. So let's see, line 365. So we have evaluate expression there. So yeah, all of these kind of areas won't need to do the. Will they take a reference to the arc-mutex? That would sound strange, I feel. Is it idiomatic to call the arc-mutex a lock? It's called data up there, and then you lock the data. Not sure. And so in this case, would you clone that? You could, in this case, you could probably pass it indirectly because it's not being used throughout the rest of this function, I don't think. Yeah, so so I'm going to ask to bear with me. For this next bit, I'm probably not going to be talking too much. That'll probably be a relief in and of itself. But I'm probably just going to focus on resolving the errors. I'm not necessarily going to be knowing what I'm doing at all given points. I'll just be, using a mix of what the compiler tells me and my own kind of gut instinct to see what makes the most sense at any given point. So yeah, I suppose I'm just going to plow through for the next few minutes, just seeing what I can do to resolving these errors and getting all of this arc-mutex stuff working. So so let's dive in. So 347. Let's see, try removing that. Expect an arc but found an environment. So in that case, yeah, so I'll resolve that in a minute, or I'll try resolving it in a minute. 346 expected that there. So what I'll do is I can probably just hand that. Oh no, I can't hand that over because then. Oh no, I could probably just hand that over. Let's try that. 8 errors anyway. That seems like it was all right. Method not found in arc-mutex env. Yes, because we'll have to have to lock it then. All of our activities that that involve arc or that involve the environment will now need to use the lock. Might make sense to add a type in a few minutes. All right for that. So yeah, I'll come back to that. That's a get. That's a get. Assign var 244. We'll just hand that over. 194. Insert. Yeah, that'll be another arc method. 194. No, that's the line I'm on. 71. Yeah, that's a get. That's then line 34. Result. Oh, that's in main, is it? Yeah. Line 34. And what I'll have to do then is up here at the top level, new mutex new. I don't like doing that much in one statement. Don't like that name, but that'll do for now. Still have 8 errors. Not found in this scope. Yup. Mutex. Oops. 6 errors. Yes, so we've cut that down a little. So what we might do then in that case, sorry, I'm more talking to myself now at this point. So that's the old implementation. I'll probably get rid of that in time. Can I create a, yeah, it might make sense. I'm not sure what names would make sense. Like I could update that to be called just frame. No, I probably wouldn't actually, because it'd basically be the same type, only that this one is wrapped in, I'm just going to call it env2 for the moment. It'd basically be the same type, only this one has some mutex stuff around it. And the difference then is with this stuff we go self lock and wrap, and then insert oh, I should probably just do it manually to start off with, and then refactor to use types in this way. Yeah, I'll do it that way. So we'll have env insert, and that'll, oops, I'm programming Go. So we'll have an insert, and so it'll be the same as down here, but it'll take an arc-mutex. And so we go env lock, unwrap, and insert name v. I wonder what that'll do. Does that actually work? I'm actually kind of surprised at that. Okay, I won't question it too much. And then we'll go for env get, same thing again, only this time, oops, we will do option value, and same thing. Okay, so here we expected a reference to a string. Okay. Okay, and that's actually working all right. Now, tricky part in here potentially, I'm locking the top level arc-mutex, and then in here I'll be doing another lock as well. So what is yeah, that should be all right. So let me think, what does that even mean? And where, like, what does that look like in the context of an evaluating thread? So if I had something like, what was the method? So if I had line 335, maybe not that one, that's a bit more complex. 321 maybe. Yeah, so if I just had env get, and we have the top level, so we're looking to get a variable and we're being given either the top level environment or some deeper environment, then regardless, we're going to have to make sure that whatever environment we're referencing, we have the only reference to it, or we have ownership over it at that point in time. And so that would mean that we lock the current environment. So again, this could be the global environment. Whoops, no, down here. So we lock the global environment. And then we get whatever from the frame, and then we cycle through the kids until we find it as well, even though that could be a source of issue because we'll retain the lock on the overall environment even while we're going through any other. So that won't be an issue with the global environment because we won't have any parent environments. Will it be an issue for non-global environments, so function level environments? Not so much because that'll be, in general, only one function is going to be referencing its own environment, so that's not really a massive issue there either. It's definitely something I want to be aware of and to keep in mind, but get. So it's not, the issue isn't that get locks the frames, it's actually that the yeah, I need to oh, I already have, yeah. In fact, I'm just going to make a note of that on paper and come back to it personally at some point. So env get locks top level environment. And get method on env locks actual frames. Is there a need for env get to lock the top level? It's kind of env get to lock the top level. Like there is, right now, because I can't think of a better solution, but it might not actually be necessary. It's an interesting one. Anyway, I'll update all of those env gets to use this new setup. Whoa. Why can't I? Because I need to do. Oh, what? Yeah, pipe. So if I go Control W and pipe, no. Okay, yeah, confusing myself. My muscle memory wasn't firing. So yeah, so let's see, line 3, 2, 1. Let's try this out. So we go env get instead, and that'll be env 335 env get there. Let's see if those work first. Should go down to 4 errors. Yeah, nice one. 194. Env insert env and hopefully 3 errors. Yeah, nice. 54. Oh no, that was 44. 54 env get env name. 71. That's an insert. And 347. Let's see what we need to do there. So we need to wrap it in a new arc-mutex, I'm guessing. Don't love the locked ends again. Interesting. Okay, 19 errors. Let's see. Can't move out of dereference of mutex guard 433. Move occurs because it doesn't implement the copy trait. Consider borrowing the options content. Oof. This is tricky stuff. Let's see, is there anything else? Is it all the yeah, some of the others should be more straightforward. So we have, what, 19 errors at the moment. Maybe I'll just, to get the types working, I'll just do that and focus on some of the hopefully easier errors for the moment, and then revisit this one because this looks a bit trickier. So 403 can't move out of dereference there. Can't move out of dereference. Not really sure what's going on with that. Can't move out of dereference of mutex guard. Move occurs because the value is type env and doesn't implement copy. Does that have to be mutable? Do I have to manually dereference it maybe? Okay, maybe I'll come back to that one as well. That's a little tricky. Okay, a lot of writing on some theoretical, on the hopes that I can fix some things in theory. But yeah, we'll cross that bridge when we get to it. Eval 366. Move occurs because that, and it doesn't implement copy. Value moved here in a previous iteration. Yeah, so I should be able to, that should be all right. Yeah, so just clone the reference, and again, yeah, absolutely. Borrowing is a bit of a minefield, and definitely open a can of worms with this. But again, it's like again, same lecturer in college said one of the nice things about functional programming, I think, is yeah, you have a lot of headache getting the like types to match up and all these kind of things, but then at the end, the finished product usually works how you expect it, hopefully. So or usually works a bit closer to what you expected than the yeah, exactly, pays off in the end. I think so too. I definitely think borrow checker is one of the most innovative things we've gotten in programming languages in the last while, but it doesn't make it any easier to use, I have to admit. So let's see, value used here after move. So it was moved in the get, in an env get, so we can clone that. And same on line 329. Probably just do the same for all the other references as well that are complaining about multiple uses. Can just again, it's kind of a fire and forget approach to a certain extent, but it's feasible because again, everything is protected by these mutexes, so it shouldn't be too problematic. It should at least be correct. It might impact performance, but it should be all right from the performance side of things as well. Moved here in an iteration. Yep. 264. What's happening here? Value moved. Oh yeah, iteration. So 140. Oh yeah, sorry, it was moved there, so I don't need to clone in the last one. I can just hand over ownership. I think. Oh no, because that's in a loop as well. So both of them need to be cloned. And there's probably something up there as well. Is that line 120? Yep. 112. Yep, that's in a loop. And 97. 88 value moved. Oh, sorry, so it's up here, it needs to be cloned, but then it doesn't need to be cloned down below, I don't think. 71. Yeah, so that's all right. Yeah, so what should be happening in each of these is that I'll be handing over ownership of the environment, but it'll be basically returned to me at the end of the env-get. I wonder if it'd make more sense to pass references to the arc-mutex and then clone it within env-get and just kind of make it that bit more lightweight. But yeah, I'll focus on getting it working first, and then maybe optimize that kind of side of things later. So that'll use here after move. So that should be that. Whoops. And 3 more errors. A valid statement on line 21. Again, same. Yeah, that's in a loop. 237. Oh, this is actually the same thing, but I thought it was trickier. Okay, private field being accessed in mains. So if I jump to the definition of env, just make those public. Big bunch of warnings here. Yeah, I'll be good, and well, one thing I'm not doing right now is actually so none of the variable lookups will actually work, which is interesting, and variable insertion into the environment won't work. So it'll be interesting to see what happens if I evaluate a program over here, but we'll see that when it comes to it. First, I'll try and resolve some of these things. So that's not being used, that's not being used, unused variable, associated function never used, and then unused result. That's a bit more relevant. Ah, yes. So this comes back to the actual definition of the function. So at the moment, yeah, so I haven't supported returning variables. Eval statements is not using the yes, so the only thing that I might need to do here is if an error is returned, then turn error. Yeah, at the moment I'm not even adding context at the moment. Oh no, 2D word. And oh, what happened there? Oh, can't find it. That should be an if less, shouldn't it? Okay, so that's the program compiling at least, and still get so the program itself that I'm compiling is this one at the moment. So where is it failing? Location 24. So if I put, and again, mentioned this previously, haven't got the most sophisticated error handling yet. So I just put everything on one line to see where the errors are being thrown. What invalid token at location 21. Oh, division. So I don't actually support division yet. So do I support addition? I think I do. No, I don't. Maybe what did I add in the first sample code? So I support less than. I support plus equals. So maybe I can just do that. and it'll be, I'll print that. Yeah, and that's quite cool. So yeah, even though I've none of this actually implemented now, but yeah, as we can see, uh, insertion isn't defined, and actually retrieving things from the environment isn't defined. So even though I am defining half up here, it's saying half isn't defined because none of the implementation logic is there anymore. So so let's get to that. Let's see. So we'll pull that out again. And this, yeah, I feel like this is going to be tricky. I thought it'd be more straightforward because my impression was, you know, we're pulling a reference. Yeah, parsing was working thankfully, so it's just implementation details now. Yeah, it's just have to implement it now. How hard can that be? So let's see, 435. Move is occurring because the value has that type. In fact, oh, can I just do, because the type option doesn't implement the copy. Okay, so I'm using a while here, but maybe it would be easier to do something like this. And option doesn't implement copy. Consider borrowing the option's content. So that takes it out of the, yeah, we'll try, first just try doing what the compiler tells me. Oh, yeah, because it's taking it out as a reference, so that's no good maybe, but if I do it like that, no. So what was the issue that I had there before? Let's take a look at all the errors that I was getting to. Oh, did I mess up my screen size a bit there? So how many errors? So I have 2 errors only actually. That's, you know, that's not too bad. Parent, I'm getting the same thing above, so maybe I could do move occurs because it has an option type and it doesn't implement the copy trait. And so, but what does asref do? Is that going to take the contents but panic on Rust as ref? No. Option. Let's see, and we have asref down there. Converts from an option. Oh, interesting. But I assume, oh wait, no, it probably doesn't matter which, yeah, whether it's a sum or a none, it'll just return a reference to either. Borrowed value doesn't live long enough as ref. Oh yeah, that makes sense. I think. Yeah, lifetimes, nice one. Yeah, that's what I get for reorganizing the while loop back at the start. So let's see. One thing I could potentially do is turn this into a loop and use breaks potentially, which is one thing I was considering there. So if I got, so I'll still have the parent prime there, and we'll do if let some parent. Maybe, yeah, getting tricky, getting very tricky, isn't it? Okay, I'll comment this out. Doesn't help that I'm like not making it easy on myself with the variable names. So within this block, if I'm accessing the parent and it actually exists, then I'll assign it to P. Otherwise I'll break, and this doesn't look so elegant for now, but if it gets me where I want to be, then I can clean it up later. So let's see. Lock and unwrap that to get env. I can get the frame. And then there's nothing in the frame. I can get parent, assign to that. Let's try that. Parent lock, you might have wanted to use an available field. Maybe that. Oh, I haven't actually taken that out of the again, looking very shaky here, but if it works, then I don't mind. So so some p is equal to what am I even doing here? So this needs to be non-option. So this will need to be an actual arc-mutex. What's it called? I'm really tripping over myself at this point. So let's see. Try that. Big load of errors. 439. Consider borrowing their data moved because it has that. And it's behind a shared reference. is there. Assignment borrowed parent. And that's on line 453. Download here, move occurs because P has that type. Yeah, it's not copyable. Can't move out of 0, which is behind the shared reference. Yeah, so if I were to even, if I was to even like unroll that loop just to see what borrow issues I'd run into. So the first thing I'd do is I would say, okay, I want to actually go into that parent item and examine the frames it has. Yeah, and I'll comment this out as well. Whoops. So we'll go So if I check what's in parent, that'll fail because I need to borrow it. And if I borrow it, it succeeds. And so if I don't borrow it and I actually try to destructure it, so that's so parent 0, I'm guessing, is P in this case. So just the variable there. And it's moving the arc-mutex out of the option, but it's behind a shared reference, and the shared reference is the is because self is a shared reference. Ah, interesting. So I'm moving it out. So I'm pulling it out of the option, and because it's a reference, if I mutated it or anything, it would be an issue. So even if I put it back in, yeah, that would be it. Or even if it just naturally went back in due to reaching the end of the function, that would be a problem. So what are some options? I could say that if I ever want to do a get, could say that for the moment anyway, gets have to be performed not on references. And on line 409, a move occurs. And that was similar to what was happening with the insert as well. And I'm just kind of playing around here at this stage, but does that sort that out? No. So the next thing to do is cannot move out of dereference. And again, I'll do the same thing just to focus on what's actually happening. So the type of X is just a mutex on env, isn't it? Or no, it's mutex guard. Standard sync, isn't it? Okay. So we've gotten the lock and we take out mutex guard. Do I not own the reference to env at this point? Or do I not own the env object at this point? Move occurs because the value is type env. Cannot move out of the reference of mutex guard. Let's see. Consider the following code example. No, that's a borrowed context issue, no. Can I get okay, yes. So at best, it'll be a mutable reference. I'm not going to be getting the object itself ever. Yeah, I need to I need to remember that. So so in that case, yes, and that's what was the issue down there as well, is that I was thinking I was getting the object itself, but I'm only getting a reference. Whoops, what did I do there? Oh, I typed Z twice. So let's go back to eval. So yeah, I have to work within the confines of references, and I won't be able to move this. Oops, what's my hair looking like at the moment? Not that that matters, but let's see, can't move it out of that because it's behind a shared reference, but surely you can do destructuring on an option that's behind a reference. Oh, I've done it again. Oops, source eval. Okay, there's my brace operators. So if I instead, so the issue was I was doing it without the reference there. Okay, so then what's the type of P at this point? Let X equals P, just to see what the type, and again, silly stuff, but wait, maybe I8, just to see what the type is. So if that should be a reference to an arc-mutex env is what P is. Okay, maybe we can work with this. And was the issue before? What was the issue before again? So the asrefs was kind of working around that, pulling things out of options. Here the issue is the borrowed value doesn't live long enough. So the reference to the environment parent okay, so and I can't clone this, can I? So let's see. Let x is arc-mutex env with an option. That should be an option. And it should be a reference in there. Move occurs because value has that which doesn't implement copy. And that's where I should be using the asref. Or it was saying, yeah, I could do it like that as well. Expected an option because of that. Could I do this maybe instead of using the asrefs? The borrowed value still doesn't live long enough. And why is that? Because env is being dropped. Yeah, this was the this was the reason why the other solution probably would have made more sense in retrospect, because again, what we were saying there was that the lock gets released earlier, so the environment stack has a big list of indexes that it can use to reference the pool. But even so, that's a much trickier solution for its own reasons, because of keeping those indexes updated. No, I think might need to press on with this this solution, unfortunately. But how to work around the fact that that environment doesn't live long enough. Again, I could try unrolling the loop just to get a sense of how we could potentially restructure it. or actually now that the types are a bit clearer, I can do the restructuring which I was doing below, which was putting the if check down here so that env isn't needed anymore. Oh, but env still probably would be needed because you're referring to its parent and you can't move the item out of it unless you move the parent back into the environment again. Very, very tricky. So let's see. If I get rid of those again. So the original issue was that there were moves. I was moving that outside of the mutex guard. And the original one was moving the option outside of the self-reference. So let's see. Oops. So we have self parent doesn't implement copy trait, and it's an option. I'm probably going to have to sleep on this one eventually, but with this, so it's giving ownership to that variable, but it can't. And then if we borrow it, then that doesn't have enough of a lifetime. Yeah, it's a real catch-22. Yeah, what I'm probably going to do at this stage is, yeah, I'll probably start leaving the probably leave the stream more or less there for today, rather than kind of have a big load of blank content while I think about things in my head and on paper. I wonder, is there anything else that I can fill up the last 10 minutes with? And probably not at the moment. What's left to do? Yeah, it's all function call stuff. Oh, thanks very much. Yeah, this is going to need a long walk to think about as well. Yeah, I think there isn't much time left in today's stream anyway. Hoping to get back to the regular hour next week. So usually this is starting at 3 o'clock. I have some business to take care of a little later on today, so I'll leave it there a little bit early today. But what's it? Yeah, it's an interesting challenge. This is definitely the most challenging piece of the puzzle so far. A lot of the features were kind of writing themselves so far. So it's it's probably good that there was some meat in this to make the stream a little more interesting. But yeah, today finding it lifetime is just a little more bit tricky. I have to brush up on those as well. But anyway, thanks to everyone for watching, and thanks Gambuzi and Twitch Live Lover for messaging in, and yeah, I hope to see everyone next week. Thanks. Take care.